Hello, everyone. I think I saw some people waiting on YouTube. Let me know real quick in the chat if you can hear me. It's always good to have a double check on that. And that you can see my screen. And I forgot there's a little delay streaming. So I should be streaming now. Someone said, good afternoon. I hope you can hear me. Hello. We're going to wait just a couple minutes before we get going. But yeah, everyone already here watching, feel free to introduce yourself in the chat. It's always really cool to see, where people are watching from, what you're working on. If you want to share a project or why you're interested in AI observability, let us know in the chat. There's also in the YouTube live stream, if you're watching on there, all the relevant links should be in the description. I'm going to share some in the comments right now as well, or in the live chat. I'm not sure if they're clickable in the chat. But basically, the only thing you'll need to do for this workshop for setting up is create a free YLabs account, and then also make sure you have a Google account, because we're going to be using Google Colab to actually run our Python code. And again, most of the links that I share, unless it's something that comes up outside of the workshop, they're all in the YouTube live stream description. So if you want to get set up, go to the free account. And also, I always like recommending people to join the Slack channel after workshops. A lot of people tend to have questions when they start using it on their own data. So joining the Slack channel is a great place to stay connected with hopefully everyone that's attending this. I'm in there, other team members from YLabs and other people that work in the MLOps space. So it's a great place to go ask questions, especially after this workshop. If you're going to start implementing some of the things we talked about on your own data set, a great place to stay connected in there. Someone said they're a data scientist, and I'm summarizing your text. But it's also cool. It looks like you worked in manufacturing performance monitoring. That's awesome. That's actually how I got started in machine learning and computer vision, was actually from manufacturing QA monitoring, which I'm not sure if that's exactly what you've worked in. But that's how I got my start. So it's always fun when I hear other people working on that. All right. Looks like some people are still joining. We'll get started in just a minute for everyone who just joined. We're waiting just another minute to start, and the setup links, relevant links for the workshop, are in the description on the YouTube live stream. So if you want to go ahead and create a free YLabs account, it should take only a few seconds. You can just log in with your Google account. And then you'll just want to have a Google account, which I'm sure most people already have, just so you can save your own version of the Python notebook that we're going to be working in today. I'll put this in presentation mode. And all right, let's get going. So this is a workshop. It's hopefully going to be about an hour long. It's Intro to AI Observability. We're going to talk about monitoring ML models and data in production. So there's going to be a few slides at the start just to kind of get us all level on some concepts, but then we're going to jump into code and actually start implementing some of the things that we're going to talk about, which I find really exciting personally when I get in to like a Python notebook and actually run code and see things and then mess with it myself and then put in my own data. So that's what we're mostly going to be focusing on today, but we are going to get started with a few slides at the beginning. But if slides aren't your thing, just hang on. It won't be too long before we get to code. So what this workshop is, hopefully it's going to be a super friendly introduction to AI observability. No previous experience is expected, but knowing some Python and machine learning concepts could be helpful when we get to the code portion. But I will be explaining what's going on, so hopefully no matter what your experience level is, you'll come away from this workshop, having learned something new, you'll definitely be able to run all the code. So even if you've never done Python before, we'll be running code cells, and I'll be walking you through it. We'll cover some high-level concepts. That's the slide part. Again, it won't be too long. And then we're going to jump into implementing some of those concepts around ML and data monitoring. And just keep in mind, you can't learn everything in an hour. So this is going to be some high-level stuff, and then we're going to go and code. And hopefully, by the end of this workshop, you'll know enough to actually start implementing these in your own environment. But obviously, we can't learn everything about AI observability in about an hour. So parts of this also might feel fast-paced and challenging depending on your knowledge level of Python or machine learning, and that's totally okay. I think you'll learn a lot just by sticking through it. And then obviously it's important to keep learning after this workshop. So I'll point to more resources afterwards, and then I always say the best thing to do is take the concepts you learn from a course or a workshop and then apply it to your own data set or your own models. It could be your data and models in this case. Quick introduction about me. I'm Sage Elliott. I'm a machine learning and MLOps evangelist at YLabs. At YLabs, we do really cool stuff around AI observability and ML monitoring. So we're going to be using some of our tools today. We have an open source project that I'm really excited about, as well as an observatory platform. For about the past decade, I've worked in software and hardware with startups and agencies around Seattle, Washington, and also Melbourne, Florida. I always throw that in there because it's always funny. There's always like one person in the chat that happens to be from Melbourne, Florida, or knows where it is, which is, it's kind of a really small town of Florida. So if you happen to be in the chat, say so. And then I love making things with technology. And I will also say sometimes I talk fast during talks, so I kind of apologize in advance. You can tell me to slow down, and I might do it for a while, but then I always pick up speed again. But we're able to get through a lot that way. About you. So whenever I do some sort of live stream or workshop, one of my favorite things to do is actually learn about who is watching and joining. So if you're watching this right now in the live chat, you should post in there, where you're watching from and why you're interested in data and ML monitoring. And then also, again, the Slack channel, the link is in the description, and I posted it in the chat a little bit ago. There's a Slack channel where you can stay connected. So also, if you're just watching the recording of this and you want to introduce yourself, there's an introduction channel there, which I definitely recommend joining and saying hello. So I'm going to give people a few seconds to introduce yourself in the chat. And again, I know there's a slight delay from when I'm saying this to when you're seeing it. So I might pause for a second here while people are typing. And it might seem a little off to you if you've already typed it in. I haven't seen it yet. Has anyone done any data or ML monitoring before? That's also another fun thing to include, or is this going to be all new to you? I'll keep going on the slides. Again, I know there's the delay, so I'm going to come back when people introduce themselves, probably in the chat, but I'll keep moving on with the slides for now. Setup. So just a reminder for people who joined since the beginning, you'll just need a Google account, and then you can also go to ylabs.ai/free. And this is going to be a login for one of the platforms or tools that we're going to use today. So what is AI observability? Well, it's kind of the collection of statistics, performance data, and metrics from every part of an ML system, which there could be a lot in your whole pipeline. And then you want to deliver some sort of actionable insight from all that data that you're collecting, right? So that could be you have an environment, you're running live inference, batch inference, you're training and testing your models, you have a feature store, and then you have some sort of tool that collects that telemetry data. In this case, today we're going to be using something called YLogs, which is an open source library. And then you typically want to send that data to some observability platform. That could be something that you make in-house, another tool, and then you can gain insights from it in a visualization layer or use it to check for certain conditions, such as like data drift, which we'll talk about in a second, and then trigger something in the pipeline, whether that's alerts, talking about anomalies, or actually something else like retraining a model based on what's going on with your data. Why is it important? We have a saying, good things happen, or I messed that up. Bad things happen to good models, which is on my shirt right here, actually. You could train a model and it could be working fantastic on your initial data set and maybe even your initial real world input data. But over time, data tends to change and quality issues come up. And then also sometimes your model no longer really fits the outputs you're looking for. So we're going to talk about data quality and data drift briefly, and then we're going to get into code and implement some stuff to monitor for this. And again, like data quality can happen at basically every step of the pipeline, which we'll talk about. So data quality, if you're not careful, poor data quality can cause your pipeline and models to fail in production, which is not only undesirable, but often pretty expensive. Definitely depends on what your model's doing, but if you have something fail in production and you don't notice it for quite some time and you're just not making the proper predictions, it can be very expensive. And that could be something like actually, I think I have some examples on the next slide. There can be external changes. So I've worked a lot with computer vision in the past. So I've actually had a fair amount of stuff happen where an input sensor is damaged in some way it's just not collecting data well anymore. The data was manually entered wrong, or a camera is pointing in the wrong direction. Again, I put that in from a computer vision perspective. And then also you have things like schema changes, like a software library outputs a different format than before because they updated it and you just weren't paying attention perhaps to the documentation or they did a breaking change without telling you potentially. And then in your pipeline, there could be bugs in all sorts of places. If you've ever built some sort of data or ML pipeline, you've probably experienced some sort of bug like this before. And real quick, again, let me know in the chat if you want to put in there, what kind of data quality problems have you experienced in your work or in your projects if you're learning. We have data drift. So input data for predictions are no longer as close to the original training data set. So basically, right, typically, this is kind of an oversimplification here, but you have a trained model, and then you're collecting data and making predictions on it to use in your application in some way. And so in this case, you train a model on a training data set, and then the input data that you're collecting now is no longer really maybe super close to what you trained the model on. So there could be a lot of things that cause this, and then potentially your model just may not be performing accurate predictions anymore. So just some examples of this could be seasonality changes. Again, I use computer vision examples because that's been a lot of my background. So there's actually seasonality in images, right? For example, if you were detecting some sort of animal with like you're doing object detection where you're segmenting out where an animal is inside of a photo or a video, and your training data had all green grass in the background because it was in the summer. And then in the snow, now this animal's, or in the winter, now there's snow on the ground. So this animal's in a white background versus a green background. So there could be a big drift in data there even. You could have a new group of users that are starting to use your product that your model just didn't capture data on initially for your training data. And consumer preferences may have changed over time. Again, let us know in the chat what examples you've seen. And so I kind of like to think of this as the input to your model that is in production is changing, and we're just probably not getting as accurate predictions as we could be anymore. And a little bit similar but different, we have model drift. The incoming data per se didn't really change, but the output no longer matches the results that we're looking for. So in this case, we're getting the same data, and our trained model just isn't really representative of the world anymore. So some examples of this. One I like to use is the housing market. So if we had a very simple model that just took in, let's say it was a square footage of the house and the number of rooms, and those are the only two parameters that we're making a prediction. The data stayed the same. The rooms are the same in the house, the square footage is the same in the house, but over the years, the housing market has gotten way more expensive. So if you had a model trained 10 years ago, and then you pass in the same data for that house, the price predictions would be wrong. So you want to make sure that, in this case, we are updating our target values for our model and retraining it. And COVID-19 is a good example of this as well. So I think COVID-19, when everyone kind of shut down, that broke a lot of forecasting models. There was a big model drift happening there. And again, let us know in the chat. I think I see some comments in there, but what examples have you seen of this, if any, before? And so I always think of this as kind of the input data isn't necessarily changing, but we're not getting the accurate predictions anymore representative of the values we're looking for in the world. There are other areas of data and ML monitoring that we won't get in today. Model explainability, which is really exciting, where you're actually kind of looking at the model and understanding more about like what features are important for making those predictions. And then bias, so kind of segmenting out your data set and understanding, if it's biased in any way. Out of those two, there's more in the field as well, but out of those two, what would you want to see a workshop on next? Because we're probably going to do one of those soon. Let me know in the chat or in the Slack later what workshop you'd want to see next. All right, so I told you it wouldn't be too long of slides. So enough slides for now. Let's start implementing some monitoring. So again, these links, if you're watching on YouTube, should be in the description, and I'll share them in the chat just to make sure. So we'll want to open up this Google Colab link, and I'll talk about Google Colab in a second. And then if you haven't already, you want to create a YLabs account. And I know I'm streaming over to LinkedIn as well, so I'm just going to post these real quick in the chat there, in case anyone's watching over there. How's everyone doing so far? Oh, cool. I see some more comments coming in. Someone said model explainability should be in the next workshop. I think we'll probably be doing that one. That's the one I was leaning towards, so excited to hear you say that. All right, so once you open up that Google Colab link, and again, if you're watching on YouTube, it's in the description, so go ahead and open it up. You'll get something that looks like this. This is called Google Colab. It's essentially Google's way of hosting a Jupyter Notebook. If you've never used a Jupyter Notebook before, it's a really common tool in data science and machine learning where you can run code and write and see output all in one place. So it gives you this really nice kind of long page of code and all sorts of stuff you can do in here. So if you want to follow along, which I definitely recommend you do, you're here at the workshop, hopefully for that reason, go to File and hit Save a Copy in Drive. And so this should just take a second, a minute at most, and you'll get a new copy of this. So this will now be your copy saved in your Google Drive, and you can edit this as much as you want. You can save it, but you can always come back to this original copy. So if you do mess it up, which I totally encourage. You should be messing around with code and running everything. But if you do mess it up too much at some point, you can come back to that original one and just make another copy. But this is going to be yours now. So any edits you do in this, no one else will see it. This just lives in your drive because we're going to get an API key that you'll want to update in here in a minute. Did anyone make a copy of this? Let me know in the chat. And I'll just talk a tiny bit about Colab while people are maybe still making a copy. So I already said it's kind of their way of hosting a Jupyter Notebook. It's really cool. We don't need to do this at all in this workshop, but you can actually go in, change runtime type, and select a GPU. So you actually get a decent amount of free GPU and TPU time, which is pretty cool. So if you're getting started in deep learning or something like that, and you want to accelerate it to train models or run models, it's a really good place to get started if you don't happen to have a GPU at home in like a gaming laptop or a PC. So like I said, you can write text in here. If you double click in this text cell on your own copy, it'll open up like this. To get out of it, you can hit Shift Enter. So you can edit text in there, hit Shift Enter. And then we have a code cell right here. You can get rid of the output by clicking this. So to run these code cells, which is what we're going to be doing, you can hit this little play button. The first time you run a code cell, it might take a minute. It's just because it's kind of spinning up your own instance here. So the first one takes a minute, but then once you run one, you'll kind of have your own instance running, and then everything should run much faster. So here we printed hello. We could add hello world if we wanted to be a little bit more classic. And if you're new to Python, this is a print function where we're just kind of printing out a string. And then, like I mentioned, it's actually kind of a whole instance here. It's not just a Jupyter Notebook. So in order to run all the code here, they give you a Ubuntu virtual machine, and you can actually even run terminal commands. So if you happen to know any terminal commands, you can run them in here, starting with the exclamation mark, and ls just kind of lists the directory. So we can see that there's a folder called sample data that kind of comes with Colab here. But now we've run our first code cell. We are ready to keep running the other code. Is everyone ready? I see someone said they copied over. Thank you for letting me know. All right, so we're going to go ahead and install our dependencies. We only have one library that we want to install. And the reason for that, I forgot to mention, is Colab also comes with a whole bunch of different libraries pre-installed. So we actually have TensorFlow and scikit-learn and all the stuff that comes pre-installed here that we don't need to do. So same with, like, we're going to use NumPy and we're going to use pandas. But if you're running this notebook locally in your own environment, which if you wanted to, you can actually hit File and you can hit download and then download it as a Python notebook. If you wanted to run this locally, you'd have to install those other packages in your environment. The only one we're going to install is ylogs, which is an open source data logging library. And I do have this up here. The link again is in the description. I'm going to post it in the comment. And if you want to give it a star, that's always great. So we're gaining a lot of momentum with users. And it's just exciting to see people kind of star our library and use it more. We'll talk more about this in a second as well. But we're just going to pip install it. And we're going to install some extra dependencies there called ylabs and viz, because we're going to write these profiles, which we'll talk about in a second. We're going to write them up to the ylabs observatory. And we're also going to use some visualization. So in this workbook, we're going to create some data logs. We're going to send those data logs to an AI observatory store. And then we're going to use that to kind of visualize and detect some anomalies. But then we're also going to go in and talk more about using just the open source product or project in your own environment, whether that's locally or in a different cloud environment. So let's go ahead and run this code cell. We're just importing those libraries. So if you're new to Python, again, we're just importing these so we can use them in our project. We're importing ylogs as y, numpy as np, pandas as pd, and then datetime and os, some other dependencies we're going to use. And then we're also importing from scikit-learn, which scikit-learn is a very popular machine learning library. We're importing a couple of things here, one called train test split, and one called load iris. So I don't want you to freak out if you've gone through a whole bunch of different machine learning tutorials before. We're not just going to focus on training a data set on the iris, or training a model on the iris data set. It's going to get more interesting than that. So hopefully I don't lose you here. We're just going to train a baseline model, and then we're going to do some stuff to monitor it and then run in new data that might be good or might be bad. We'll find out. So here we're going to load in the iris data set. You can see that there's the target features. Basically, there's 3 classes of flowers, and then there's 4 features that make up those classes. So we have our sepal length and our petal length and sepal width and petal width. And if you didn't know, like I didn't know when I was first looking at this data set a long time ago, sepal is kind of like I think it's like a under petal of a flower is the best way to describe it. So you have like the flower petals you think of, and then there's kind of little things that drape off under the flower. And then quickly, we're just going to go ahead and train our machine learning model. Again, we won't go too deep into this, but we're just importing neighbors, which is a type of machine learning model, k-nearest neighbors. And we're going to set the parameter of 5 for n neighbors. This is I'll talk about this in a second if you haven't used k-n before. But essentially, it's a hyperparameter that we tune in the model, and it changes the way that it learns the representation of the data. So then we're going to use train test split. We're just going to take that iris data set. We're going to create 4 variables here: x train, x test, y train, y test. And then we're splitting it on x and y. So that's the x is the feature data and y is the target values. And then we're splitting up. So 70% of the data is for training, 30% is going to be for testing real quick, and then our random state is 42. And then we're going to stratify on y. Stratifying just means that we're going to try our best to get equal amount of classes in our training data set. So instead of just randomly selecting where maybe we didn't get any of one of the classes, we're going to try to get a pretty equal representation in our training data set. And then we're going to run fit, which is basically training. We're passing in our X training data set and our target values, and it's going to learn, right, these features correlate to these types of classes of flowers. And then we're going to run our prediction, and then we're going to get a score return. So this is just the accuracy of our model based on our validation data set. So if you've never done machine learning before, which I assume some people here have, you just trained maybe your first machine learning model. Let me know in the comments if it happened to be your first machine learning model. That'd be kind of fun, because now you totally know machine learning. And just like I mentioned before, just as a quick intuition on it, so it's a little oversimplification again, but Canaan, we had our number 5 here. Essentially, it's going to map out the data, and then it's going to look at the closest neighbors of the new data point. So if this black dot was a new piece of data coming in, and this is the sepal length and petal width of it, it's going to look at, in our case, the closest 5 neighbors, and then make a decision of what class it belongs to. So in this case, let me zoom in actually a little bit. Can everyone see my screen okay? No one said they couldn't, but I feel like it might have been a little small. I think that looks better. Let me know if that is better for anyone. All right, so in this case, if it had 4 and 3 of them are looking at versicola, it's going to predict this is probably a versicola. All right, so we have our model. We're done with our machine learning part. Again, this isn't a workshop on training machine learning models. It's going to be on monitoring data and monitoring the model after we have that. So here, this next cell, this looks a little ugly. I'm just importing a bunch of data frames or CSVs that I'm turning into data frames. Imagine these are data batches. So if our model is going to be in production, we might have these batches of data coming in that we want to run predictions on. So I'm importing the CSV. These are just the feature names again that we already talked about. And then some of the CSVs had target values in them. So the what class does the features belong to, the versicola, setosa, etc. And I just wanted to get rid of those real quick just to just do predictions on them. And then we are going to use those target values later, though, to do some performance monitoring over time. So we run this. We now have our data batches. And you can read one in real quick. We just have this array of data frames. And you can just see this is what it looks like. There's very long numbers in here. These probably should be rounded. But you can see that these are the kind of sepal and petal length and width numbers. All right, so we're going to go ahead and create a log. Any questions so far, by the way, let me know in the chat. I know we didn't get to the monitoring part, but the chat is fairly quiet, and I see quite a few people watching. So I just want to pause, make sure. How's everyone feeling so far? Good, no? Everyone's quiet today? All right, so we're going to create a log with ylogs. So you can read way more about it on our GitHub or in the documentation. But ylogs is an open source library for logging data of almost any kind. With ylogs, you're able to generate summaries of their data sets called profiles. And so we'll talk about that in a second. With these profiles, you're able to track changes in your data set, create constraints, and quickly visualize like key statistics about your data set. So we talked about monitoring for data drift and everything like that. We're able to do that with these profiles, which is pretty cool. And the profiles generated are efficient. We have a blog post, I believe, that's out talking about how fast they are. They're customizable, so you can do, like we were saying, logging almost any type of data that you need. And then they're also mergeable. So if you're using streaming or batches and you want to merge them together, you can actually merge these statistical summary profiles together and then log them, which is pretty cool. I see somebody asked a question, where is the model ID in YLabs UI? I'll get to that in a second because we're actually going to set that up very soon if you don't find it by then. I feel like I had something else I was going to say, but got distracted by the chat. All right, well, let's go ahead and look at a profile. So to create a profile, it's very easy. Once we have ylogs and pandas imported, we're just going to basically say y.log and then pass in a data frame in this case. But you can also pass in other types of data, such as dictionaries. So here, I'm also just going to update a setting real quick in pandas so we can see our whole data frame. And then here, let's go ahead and log one of our batches of data that we brought in. And then we're going to create what's called a view, so we can kind of view it in this way. And then we're going to write it out in pandas. So here we have a view of our log created with ylogs. And we can see these are kind of all the statistics that are kept about it. Something that's really cool here is, right, we profiled the whole data set, create these statistics out of it, but then there isn't really any raw data in here. So we're just using these statistics to kind of calculate those things like data drift and model drift. And the cool thing about that is, so if you have something like, if you're working in the healthcare industry or finance industry, somewhere where you can sometimes be a little bit more stringent with where you pass data, you can actually create just these statistical profiles and then move them around without really any raw data tied to them, which is pretty neat. So here we can see there's cardinality estimate, which in this case, I think our data frame here is 300 rows, and it actually is saying, basically every row is unique. Cardinality is essentially estimating how many unique values are in your data frame here. And that's because we saw those really long numbers, right? So if they were rounded up, they'd probably have a lower cardinality here, but basically saying every single row is actually a unique number. We have other distributions, so like the max, the mean, kind of all the things you would think about distribution-wise for numerical values. And then you can see some other stuff over here, such as like the data types. So in this case, they're all 300 of them are fractional. But if we had types like strings and things like that, those are counted in here as well. And now we can use this profile with all these different statistics to calculate things like data quality constraints, which we'll talk about later, and then also monitor for data drift and model drift, which is pretty cool. So again, links are in this notebook, so hopefully you're following along, or you made a copy, or you'll come back to this later, and you want to read more about ylogs, go to GitHub here. This is just a super brief introduction. There's a whole bunch of stuff you can do with it and a whole bunch of different integrations you can use it in as well. So let's go ahead, and we're going to write these profiles to ylabs. And I had a break in here just in case if someone hit run all, because you can run all these code cells, it'll break here. And then that is because you need to update your access tokens here before you can actually send these profiles up to the AI Observatory. So I'm going to go ahead and go to ylabs. Again, hopefully you already created an account. If not, the link is in the description below. And also grab it again for anyone who doesn't have it. And I'll share it in LinkedIn again real quick too. And LinkedIn comment. Go back to my copy. All right, so once you sign up, you'll see a page like this. Mine already has a couple projects in it. You can see some errors going on. Yours won't be like this because it'll be blank, or you might have one demo project in here. And then we're going to go ahead and create new project. Create project. Just noting, we're not going to do this for the workshop, but if you don't really want to follow along getting your own data in there, you actually can add a demo model. So you can hit add a demo model here, and it'll upload some other data that you can poke around with. But I do recommend let's go ahead and set up your own data model, because this is what you'll probably want to do after this workshop instead of just messing around with a demo one. So we'll go to setup model, give it a name. I'm just going to call this workshop. I'll say workshop iris, but you can call it whatever you want. Obviously, you want a relevant name, and then we're going to go ahead and say the model type we're expecting is going to be a classification model, because we are going to look at some model performance metrics later. And we'll need to set this to classification or regression if we want to look at model performance, meaning like tracking accuracy and F1 score and everything like that. So we'll go ahead and create project. And so someone asked where the model ID is. Once you create a new project, you'll see the model ID here. So mine is model 33. Yours will probably be model 1, unless you've created a model before. So I'm going to go ahead and change that variable out. And then let's go back to the platform, go to settings, go to access tokens, and then let's go ahead and create a new token. Again, I'll call this workshop iris. You can put an expiration date if you want. I won't for this one. I'm going to hit create. And then your token shows up here. So it only shows up once. So go ahead and copy this. Otherwise, you'll just need to create a new one. And then I'll copy over my token there. And then if you're looking for your org, it's also on the same page. It's right here. It's also always living up here. So you'll want to copy this over as well. And I know sometimes for whatever reason, I'll actually accidentally copy on like an extra space or something. So just make sure there isn't any extra spaces in here. Otherwise, it might not work. So let's go ahead and I'm going to hit Shift Enter. Again, you can hit that play button if you want. And I got no errors, which is pretty cool. And then I'm going to go ahead and run this next cell, which is we're going to import the YLabs writer. Oh, by the way, I forgot to mention when we installed YLogs here, I think it threw a couple errors just saying something wasn't compatible in Colab, but it should work. And same thing here. Just sometimes the Colab dependencies are a little weird, and you'll get some sort of error saying like a library isn't the one you need. But I think we should be good. So let's go ahead and write a single profile up. So remember, we imported, this is a data frame essentially of those iris feature values. Basically, writing a profile to YLabs is only 3 lines of code. So you just want to import the writer or initialize the YLabs writer. Then we're going to create a profile if you haven't already done so. And then we're going to write that profile up to YLabs. So let's go ahead and run this. And it should take just a second. Returns true. Let's go back to our platform. Let's go ahead and just go back to our project page so you can hit home. And you can see that it actually says, there's some stuff in here. If we had looked at this before we pushed it up, it would have said they're not reading any profiles. We can see that there's some lineage dates down here, and we can see, there's 4 inputs, and currently there's no alerts in range. Let's go ahead and open this up, and you'll see we have our feature values here, and we can go ahead and click in. And now this isn't super useful because it's just one profile for one date, so we're not really seeing like how to monitor something over time. So let's go back to our notebook. And I just wanted to show you that it's really only 3 lines of code here to write a profile up. It's really easy. So if you're actually in your actual pipeline, it'll probably be something like this. By default, the date and time that gets passed to YLabs is the current date and time. But what we're going to do here is kind of backfill our data so we can look at data as if like we were running this for a week. So this looks a little bit more complicated, but all we're doing is just enumerating over those data frames that we have. And then we're setting the date time, and then we're subtracting a day each time it loops over, just so we're kind of backfilling for the week. And then we're doing the same thing, creating a profile on that data frame, passing it the timestamp. So we're saying set data set timestamp. Again, by default, it'll just do it at the date and time that you pass in. But if you do need to overwrite that, you can here. And then we're going to write to YLabs. So again, let's run this. Should take less than a minute. By the way, occasionally with Google Colab, I have gotten some error saying an SSL cert error or something like that. And if that does happen to you, disconnecting the runtime, you go to runtime, disconnect and delete runtime, and then running everything again should fix it. I've only had that happen, I think, if I've had the Colab notebook up for a while and then I go do something else and for whatever reason. But hopefully you didn't get that. So let's go back and let me go back. So if I just hit refresh here, well, if you had just hit refresh there, you might have noticed that nothing changed, and that's because I think the date time wouldn't have changed, except for I went all the way back and then forward in. So you just want to make sure that your date time is always selected here of like what you're actually looking at and not accidentally only on one day. And another quick little fun navigation technique is if you're on the profile page here, with all the projects, you can actually click in here. It'll have the lineage of like this project has data from all these different time frames and days. You can actually click in here and it'll automatically assign those dates up here. So I use that all the time just to make sure I get all the data. If I want to look at the full data. Sometimes I want to look at specific date ranges. All right, so now we have inputs. We can actually go and see that there's profiles in here under this profile tab. And we can select multiple profiles to look at. So if you click on this, you can kind of get some distribution. These ones look funny for a reason. We'll talk about that in a second. We can see some kind of distributions of these length and width measurements. And then you can actually compare profiles together. So if we want to, let's add another profile. I think this one's another good one. I forget which ones were what. 1 What am I doing wrong? There we go. I think I had a profile that's purposely bad that we didn't get to yet. You can see that these distributions of these petal and sepal lengths and widths are actually pretty similar, right? So we could say, well, they look like they're probably haven't really drifted too much. We can go to view details here, and we can actually see that they're very similar. The distributions are almost the same. There are some slight different amounts in those buckets that we would expect. You can even change binning. So this is a cool way of like comparing profiles together too. You can go up to 3 and kind of see how those distributions align. But the really exciting part is, let's go back to this inputs tab. So we can see that we're collecting all these different feature inputs and get a little bit of data about them right here. Let's click in further. So let's go to this top one, the petal length. We can see that visually, without even in some sort of alert or anything set, we can just visually look at this and probably take a guess if that that something is probably wrong here, right? But the cool part, like we were talking about, we want to have a tool that monitors this for us, so we're not always manually checking these things. We can go to Setup Monitors. So you can go to Monitor Manager in this tab, or right here you can click this button if you don't already have a monitor. Setup Monitors. What we're going to do real quick is we'll just enable this one with one click, and then we'll talk about extra configuration that you can do. But we're going to say we want to monitor for data drift in all model inputs. So all non-discrete values, all the numerical values, we're going to kind of compare over a 7-day trailing window and trigger an alert or say there's an anomaly happening when we think they've drifted a lot. So let's go ahead and just hit that configuration. Let's go back to the inputs. And we'll go back to that petal length. And so the reason why we could probably say that maybe something is wrong with this graph is like these look pretty similar, and then there's a big jump here. And if we measure or if we hover over this, we can see that there's that. It might be a little small on the screen, but if you're following along, you'll see that there's numbers in there. So you can see the min and max for these distributions are pretty similar, or for these profiles, until we get to here. Then it goes from, the max was around 6 point something. The max over here is now 11 point something, which is a bit of a drift. Maybe it's not crazy depending on what's going on in our data set. But if we hover over this giant spike, now it's the max is over 117. So it went from like the max values were 6 to over 117. That seems like, that there's probably a big spike of high values happening there. So let's we enable that monitor. Let's go ahead and we're going to hit preview now. So by default, the monitors run every 24 hours, and then they'll trigger an anomaly detection email or whatever you set it up to do. We'll talk about that in a second. So it's going to say like the next monitor run is going to be in 6 hours, and then so it would automatically run and then kind of detect these anomalies. So this is calculating some data drift here, saying I think, based on what we calculated, there's a problem with this profile, there's a problem with this profile, and there's a problem with this profile. And we'll go back in the Python code in just a few minutes, and we'll actually just use the open source product to take a deeper look at these things as well. So we'll see what's going on. But if you hover over again, you can kind of get an idea, because we can see the min max values here. So again, this went up, and then this one went way up, and then this other one, the min max value is actually 0. So if the min is 0 and the max is 0, basically we're saying that that profile is all zeros. So if we went into settings, and we can go to notifications and digest settings, and then we can decide what we want to do. So when an alert gets triggered, what happens? Setting up an email is incredibly easy. You just enable this, type in your email, save it. You can set up a Slack integration, so it can trigger an alert in your Slack. And then you can use something like PagerDuty here to do all sorts of different applications. So whether you want to, trigger an auto train or something like that, you could do that with the PagerDuty. Did anyone follow along and get their data in here yet? Someone asked about generating a profile without pandas. Like I mentioned, you can actually consume other data objects. It doesn't have to be a pandas data frame. So you can actually just pass in a object or a dictionary as well. And then also integrates with Spark and PySpark. And we're using the Python version, but there's also the Java version of ylogs as well. All right, so hopefully you've gotten this far, if you've been following along, and we actually went through very quickly. We actually barely did any code. Basically 3 lines, a little bit more if we wanted to backfill this. Basically 3 lines of code got data into the YLab observatory, and then you're kind of very quickly able to get these alerts that you can set up. And again, you can go to Monitor Manager. You have a whole bunch of different presets that you can choose from, as well as creating your own. So we have the drift ones that we saw. We have data quality ones, so we can detect, like schema changes, missing values. And then we have model performance, which, again, we'll get to the model performance in a minute. But logging things like F1 score and precision, and when that drops, maybe it's time to automatically retrain a model. If you're monitoring F1 score and stuff, you're getting new ground truth data probably. So then maybe you can automatically trigger a model to train with that new data. And you can go to new custom monitor, which will kind of walk you through how to set it up. So it's like, do you want to do it for drift, data quality? Do you want to look at those? Go back. Like, does it want to be like input features? Some other options here by default, and we don't go into it in this workshop, but there's different ways of measuring the drift distance between your data. So we use something called the Hellinger distance here, and you can actually change this default value to what you think the minimum drift distance should be, or maximum, to trigger an alert. So you can change this. By default, we do a trailing window. So it's kind of just looking back at the data and alerting when something changes quite a bit from the rest of the data set. But you can also do a specific reference date range. So if you want, you can say, well, I know profiles of our data were really good at this range, and we're always going to be comparing to that. You can also upload a reference profile. I have a little commented out piece of code in the notebook that can do this for you. But basically, at the beginning, if you're deploying your model, maybe you want to use the training data set as a reference profile. So you train a model, you put it out there, you want to measure the input data already happening, and then you can reference the training data set and then just kind of monitor for drift on did the new data change a lot from your training data? So I think I see some people saying that they put their data in their project. Hooray, that's exciting. And if you've never done any monitoring before, it's extra exciting, I feel like, because you just went through and implemented your first monitor, hopefully. What do people think so far? So I'm going to keep going down the code because I know we might go a little over time here, but what do people think so far? Does this tool seem interesting? Is it valuable? What do people think? And provide feedback in the Slack as well. So even after the workshop, if you go use it and there's something you find interesting, I mean, I love hearing good things about it, but also if you ever like find something that you have a question about, let me know in the Slack. All right, so here's the code I talked about where you could actually write the reference profile and compare new data to. And then also, I have code cells in here or text cells that you can expand that have kind of all these images. So if you are taking this notebook later and not watching this workshop, you could go in here and kind of see those tabs I went to and how to set up the monitor. So I'm going to collapse this back, but anything that says expand kind of has images of the platform. All right, so let's go ahead and log our output now. Now, we could do this in the same loop. I just kind of broke it down separately for the workshop because I thought it made it a little bit easier and clearer, but maybe not. So real quick, we're going to take these data frames for predictions, and then we're just going to predict all the outputs with our k-nearest neighbor model that we trained previously. And then we're going to save, or we're going to append new columns to our data frames with one called class output, CLS output, and one probability output. So we basically just got the predicted class from our model, and then we're getting the predicted probability, which in KNN, I feel like probability scores aren't great because they're really just saying like, well, these were the closest neighbors to me, and so I'm like 85% sure or something like that this is belongs to this class. And if we look at our data frame real quick, we can see that it now has the appended class output, which is just a category 0, 1, and 2. And then our probability output. So this will vary from 1 to, there's one that's like 60 right now. So this is kind of how confident the model is that it belongs to that class. And then here we're going to do something very similar to we did before, where we're really just going to pass up that data frame to YLabs. So we're just enumerating over the data frames, but we're just going to pass up, in this case, the class output and the probability output columns from the data frame. So let's go ahead and run this. And like I mentioned, you could totally do this in one loop or the original 3 lines of code, which is probably what I would do in most of my actual production use cases. But just for the workshop, I kind of wanted to break it apart where we log the input data and then we log the output data. But typically, I might actually just take the input data, run those predictions, and then log the entire data frame. But also, depending on my pipeline, I might be wanting to log my input data at various stages, right? So it might be at the sensor level when I get the original raw input from the sensor or a camera or something like that. I might want to log that, and then I might do some sort of transforms or pre-processing somewhere down my pipeline. And so I actually might log those all different steps together that would show up in that input, and they would just have different names of like what stage of the pipeline they were in. And then I might run and log a whole data frame that has the values that were passed into the model and then the model values themselves. So we go back to the YLabs. We can see they're not in the inputs, and that is because if we have the word output or outputs inside of a column, it's automatically going to separate it into this outputs tab. Uh-oh. Did I run it? Okay. I just had to refresh it. I was like hoping it wouldn't break during a live demo. All right, so we now have our columns that we just uploaded, and it's very similar to the other tabs, right? Where we can, what's going on there? Never seen that before. Let me refresh. I feel like I've never seen this jiggly thing before. Okay, that was just the size of my window or something. Very similar to what we saw before. It's just that it's in an output tab. So if you have a lot of features coming in to your models and data sets, it can be helpful to have them in kind of different tabs and break down where to look at these things. But again, very similar where you can now look at the numbers coming in. In this case, you can see the total output and input count, and then kind of the variations of them. So we can see that the min was about 60, so our model wasn't always super confident. It was about 60% on some, and then the max is 100 for a lot of the profiles. Any questions so far? Any other questions? Someone asked, can they use it with R rather than Python? I don't think we have... You won't be able to install it in like an R library, at least yet. All right, so I'm going to go through the other stuff probably pretty quickly if there's no other questions, just so we don't go too much over time. Let's talk about logging performance. And oh, I did quickly want to note again, because I feel like with the loop, it looks like a lot of code sometimes. But right, actually integrating it into your pipeline is pretty easy. It's about 3 lines of code, and then to send a profile up. So let's go ahead and log performance. So the performance in this case isn't necessarily just the probability output or the classes output. We want to log the predicted classes, and then we want to log the ground truth data to YLabs. So if you've ever done this before, you've probably calculated something like an F1 score or precision, where you're basically comparing the predicted classes versus the actual classes that belong to the data. So I had mentioned that there were, sorry, I got distracted by the chat again. Someone asked, can I talk more on multiple constraints? We will. That's actually going to be the next part. So we're just going to log these performance data, and then we'll talk about constraints with ylogs, which will be cool. So so far we've been using ylogs with ylabs. After this, we're going to go ahead and get into using ylogs kind of on its own in a Python environment. So here we're just going to basically concatenate the target data that we had separated when we imported those profiles. We can look here on this prediction profile and see that now we have not only all the features, but we have the class output, the predicted output, the probability of that class, and then the ground truth to the data. So again, I'm just going to do a loop to backfill a few profiles here. And we are creating a new ylogs profile that contains a data frame, and then we're basically saying which column is what. So in this case, the target column is the ground truth, the prediction column is the class output, and then the score column is the probability output. And then we're just profiling up or sending it up, writing it up to ylabs just like we did with the other ones. So now if we go back to our ylabs platform, go to Performance tab, we'll see that we have that input and output, the accuracy, and then a confusion matrix, precision recall, and kind of all the other metrics that you would expect monitoring performance. Again, if you want to expand this kind of shows the results here as well. So I'm going to keep going pretty fast unless there's any other questions real quick on this, just so we can get through this material, hopefully not too much later than we were originally planning. All right, so someone asked about, can we use constraints? And we can. I'll just quickly say, if you want to learn more about ylabs, click here again if you're in the notebook, or ylogs and other writers. So you don't always have to send it to ylabs. You can send those profiles elsewhere. There's a whole bunch of other little integrations there that you can work with. So before moving on, how are you feeling so far? And we've gone through a lot. We've already been able to monitor input data and performance. Any other questions so far on that? All right, let's get into using ylogs for validation directly in a Python environment. So we talked about data quality briefly in one of the slides, right? And one thing we can use to monitor data quality is something called validation. So essentially we want to say, well, does this data look the way that we expected, and does it fall into the values that we expect? So this little graphic here, right, we're just saying, oh, there's a null value. That's not what we wanted. We didn't want a negative value for our model. Maybe our model, isn't expecting negative values. And if those values exist, maybe we shouldn't even run a prediction, right? Or we should do some action based on it. So I'm going to run this code cell. This is just to make it really easy for you to play around with, because we're going to be looking at multiple profiles and setting up something called constraints. So we're going to basically say if values fall within these ranges or look a certain way, pass a test. Essentially, this is kind of a way of almost writing unit tests for your data, which is pretty cool based on those profiles that we saw before. So this way we can just quickly, you'll see this profile view number used around, and you can quickly change it out to one of these and kind of see how it behaves with that profile instead. So if we just look at profile view 1 again, right, we can see all those metrics that we had talked about before. And here we're going to want to write a constraint. We'll do a couple of them. We're going to do multiple constraints to basically say that we want to check the petal length and width and sepal length and width, are between a certain value. So we would expect that we never have a 0 value, because if there's a petal, it probably shouldn't be a 0 value, at least in my head. Like there's always going to be some sort of measurement there. And one thing we can also check is make sure that that value is a number, right, instead of a string. So if someone accidentally wrote 0 as text instead of actually writing the number 0, we might want to throw an error and never use it, because we only want to use numerical values. So to do constraints in ylogs, we're going to import some functions here. And then we're going to initialize our constraint builder, and we're going to run it on profile 8 here, which we'll see in a second. And then we're going to define a constraint. So here we're just going to do one. We'll do multiple ones down below in a second. But here we're basically just saying that the name, this is just a string. So you can call this whatever you want. I kind of like to write out the value. So I'm just saying, string type is equal to 0. Basically saying there shouldn't be a string type at all in this data set. And if there is, throw an error. And then here's the actual the condition is a lambda function. So we're saying that x.string.value is equal to 0. And then we have our metric selector where we're passing in types, and then we're going to pass in the column it's going to be looking at. So if we go back to our profile and we scroll back over, we can see that we have these types, and then in one of them is string. So that's what is happening here. We're saying, go look at types, basically types.string.value, which is the value that's in there, is equal to 0. And then so let's go ahead and run this code cell. And we get this constraints report. This says 0 and 1. So this is the text string that we wrote. And then we basically get a 0 or a 1 back in these other ones. And so this is saying fail is equal to true. So if we had a 1 here and a 0 here, that would say pass. So it would be fine. So let's set up multiple constraints and see a better way of visualizing it. So here I'm going to create a function. I'm going to pass in a profile view, and then I have a little verbose parameter that I like to put in functions so that I get more output if I want. And then here we're going to do what we did above, except for we're just going to do it like 4 times, one for each of the columns, and we're going to check that the petal and sepal links they're above 0, and they're below 15 at the max, right? So again, we can go look at our profile, we can look at our distributions, and we can see that we had the distribution max and we have the distribution min. So we're really just looking at this profile and saying that, all right, it should be below, or it should be above 0, and it should be below 15 for each of those columns. Let's go ahead and run this. This is just going to print out that report, and then we're going to get this constraints return. So this created our function. Let's go ahead and run that with profile view 1. And again, I encourage you want to mess around with this number. Do it profile view 2, 3, etc., and you'll get some maybe different output. So here we can see that for each of those constraints, we got a tuple returned, basically with what we saw before, but this time we have 4 of them. And then again, if we have a whole bunch of these constraints, it can be kind of hard for us to either visualize or check each one of them. So we make that pretty easy with this notebook profile visualizer. We get this actually nice looking report. You can even filter and for a failed one. So if you had a whole bunch of different checks, right, not just 4, you can actually filter here, which is kind of nice. And then also, right, if we're actually running a piece of code, we don't want to write probably 4+ things, depending on how many columns we have in this case, to make sure that the pass or fail is in each one. So here, we're just basically validating all those constraints. And in this case, it's true because all of them pass. So this is just saying, look at all these constraints in our builder. If they're all passed, it's true, and then you can go on. So in this case, right, maybe we don't even want to run the predictions on a machine learning model if they didn't fall in these parameters, or if there was a string in there, because it would then break our model. So let's do this again with a different profile. We'll use profile 4. And it's the same thing, but we can see that this has failed. Each one of these has failed. We'll run that visualizer, though. That makes it easier for us to see. And we can see, again, failed all of these. And then if we run that whole thing that's going to check all the constraints for us, we can see that it failed as well. And let's see why it failed. So let's go ahead and view that profile. And this is the one I think I kind of teased a little bit earlier about it's all zeros. So we can kind of tell that, well, cardinality, there's only essentially one value in our notebook or in our data frame. And basically the min, max, and everything is 0. So that's why this one failed, because it wasn't above 0. And again, if you want to learn way more about data quality validation using constraints and YLogs, you can go to these different places or these links. And we also have a really cool feature that just came out in one of our releases recently called conditional count metrics. So kind of similar where you can set constraints, except for you can do it on specific values. So instead of actually just doing it between these profile statistics, you could actually look for specific numbers or use regex for whole different string searching. For example, if you're looking for email addresses or some sort of PII or something like that, the conditional count metrics are really a cool feature for that. All right, so I'm going to keep moving along because we're a little bit over time. We're going to quickly go through visualizing with ylogs for drift detection. So let's go ahead and import the notebook profile visualizer. We're going to initialize the notebook profile visualizer, and then we're going to basically pass it to profiles to kind of compare against and get some statistics from. So we're going to pass in profile view 1 and profile view 2 at first. And we'll run this. So it'll give us some statistics about both of those profiles, total count, but what's really cool is looking at this summary drift report. This will have the profile side by side. So these are each one of the features. You can kind of see that the distributions, again, like these look pretty similar here just visually to us. But the cool thing is you can also look at this p-value score. So essentially, this is a way of calculating how similar these data sets are to each other. So the higher the value here is, the closer of similarity they are. And a cool way of visualizing that is we can actually make a histogram of each feature and basically overlay these two profiles on top of each other. So here we can see they're incredibly similar, right? Like they're basically all falling in the same spots. Some just have slightly more values or less in some of these areas. Let's look at another one. Again, same thing, very similar, basically on top of each other, right? And then let's look at some other profiles. And again, change these numbers around yourself. So if you want to just change this to a different number and see what the profiles look like on top of each other, this is a fun way to kind of explore the tool. So here we can see that, well, these visually, maybe these distributions look kind of similar, but these p-value scores are way off. So this one's saying 0, like there's basically no relation at all to each other. And if we look at the visualizer where we're basically overlaying the histograms, we'll see that, right, they actually don't overlap at all. There's actually a pretty big distance between them. And so if you looked at that profile view, this is the one where we saw in YLabs earlier, where it went from basically falling between 0 and 6.8 or 0 and 5 or whatever for one of the values to the 6 and 10. So this basically, this value is a drift. I mean, this is like a pretty big drift, right? Like there's basically not overlapping at all anymore at this point. But this is one way of kind of quickly visualizing data drift between features with ylogs, basically in any Python environment, which is pretty cool. And again, we have links to way more about visualizing with ylogs here, and another really cool example. So if you just want to learn more about it, go to one of these places. So we are just over our kind of estimated hour for the workshop. We've covered a lot in a short amount of time, and I know not all of it we got to go super deep in. I think the hope of this workshop was to give you, like, you know, high level descriptions of what to look for and how to get started. And hopefully you came away from this workshop feeling like, cool, you learned something new and you kind of know how to go and implement it now. Even if you have more to learn outside of this workshop about different types of data drift and model drift, but you actually now kind of are armed with a tool where you can go implement these in your own pipeline and start monitoring your own data and models. And it doesn't always have to be machine learning models too. In this case, we've talked about machine learning quite a bit, but you can also use this just on your data streams, right? You don't have to have an ML model. You can just be looking at your input data for anything and monitoring for data quality changes or big drifts in data. What's next? So join our machine learning Slack channel to ask questions. Again, the best thing to do is use this in your own project or something like that. And you might have a question, so join the Slack channel. I'm in there. Other team members are in there, and a whole bunch of other people that hopefully can answer questions about whether it's YLabs or not, just anything around AI and ML ops. We do have a forum too. I'll share in the chat. I might close this in a few days, but if you want to get a certificate for attending this workshop, you can fill out this form. And it's also in the YouTube description. And then obviously one of the best things to do is learn more. So again, there's a whole bunch of other links down here. And there's a lot of resources in our blog. And I also linked to our integrations. That's a pretty common question, is like, how do I do something with a specific library? Chances are we have an integration for it, but I'm going to go ahead and paste these links into the chat. So this is to the collab. If you didn't open this up or you just happen to be joining the workshop, you can go get this collab notebook. Go to Ylogs project on GitHub. And definitely give us a star, especially if you enjoyed the workshop and you feel like you learned something new. I appreciate a star on there. And then the link to the Slack channel is there as well. So if you want to join, say hello, introduce yourself, stay connected with other AI practitioners, and or ask any questions. That's the place to do it. And then the certificate link, share it again. And then if you want to stay connected with me, LinkedIn is one of the best places to do that outside of the Slack channel. Definitely recommend joining the Slack channel, though. If you have any questions, because we are a little over time, so I'm going to get off pretty soon. If you have any questions, ask me on LinkedIn or the Slack channel. And it's been really fun going through this together. Again, let me know in the chat if you enjoyed it or you learned something new. If you found it valuable at all, let me know. I always appreciate feedback, whether it's here or in the Slack channel or on LinkedIn. I love hearing from people. All right, so I'm going to go ahead and end the stream, and hopefully I will talk to some of you later. Have a good day, everyone.